Welcome to Datagaps webinar. I'm Pooja Gupta, Growth Marketing Manager at Datagaps, and I would like to thank you all for joining us today. Before we get started, we have a couple of quick housekeeping comments. First, we have muted all mics to avoid unintended distractions. Second, we have included a couple of polls which will reflect in the middle of the session from time to time. And we would request every attendee to share their feedback by answering those poll questions. And last, if you have any queries, please type it in the Q&A section. We will take them all at the end of the session. Also, platform has the capability to upvote the previously asked question. So please upvote if you have the same query. Today, in this webinar, we are tackling a silent threat to data-driven decisions. Those hidden anomalies that slip past rule-based checks and erode trust. We will explore how data observability, powered by Datagaps, brings real-time, ML-driven insights across pipelines, warehouses, and BI reports. Get ready to see how unified scorecards and anomaly detection can transform your data healthy strategy and protect the boardroom from surprises. And for this, on the panel today, we have Anand Rao, VP of Marketing at Datagaps, and Subhanshu Dikshit, Senior Solution Architect at Datagaps. With this, I hand this over to Anand and Subhanshu. Hey Anand, stage is all yours.
Great. Thank you, Pooja. And hello and welcome, everybody. Very excited to have you here. Welcome to this webinar. Today, we'll tackle a common problem many people have. The data that seems fine one day causes trouble the next day. We'll show how Datagaps combines simple rules, data reconciliation, which is nothing but the matching and balancing of data between sources and different targets, as well as any intermediate stages, as well as machine learning to spot unusual changes across pipelines, data warehouses, and business intelligence reports. We have a wide range of audience here across analytics, across ETL pipelines, as well as data quality. So you'll see how we can catch issues early, fix them faster, rebuild trust in dashboards, and measure data health in production. So here's today's agenda, why this matters now. I'll explain the current data reliability gap and why teams can't ignore it, what's breaking. We'll look at where older data quality methods fall short at modern speeds and scales of data, what observability adds, a clear end-to-end view that finds issues early and shows the impact. And then we'll do a quick tour of the platform by role, how each persona, whether you're an engineer, an analyst, a steward, or an overall leader, uses these workflows. Generative AI, of course, is all prevalent everywhere. So we'll talk about 4 AI boosters, tools that help you speed up the testing, the setup, the anomaly detection, and fixes to cut the time to value, basically. And then Subhanshu will have a live demo, a walkthrough of some of the key features in action so that you'll get a taste of our platform. 3 quick wins. I'll talk to you about some real customer results that you can relate to. And also, I'll talk about an implementation checklist where you can think about the returns you get from implementing such a data observability platform. So let's get started and dive a little bit deeper into the challenge and the problem. So the big picture is that leaders have relied on dashboards, but 77% of the companies find business intelligence errors every month. So that kills the trust in these dashboards and wastes a lot of money. Gartner, the analyst firm, puts the cost at roughly 12.9 to $15 million from all that rework, the bad decisions, as well as compliance fines. So what's really happening under the surface? About 5% of the data pipeline and ETL jobs fail daily. Now, 60% of those failures come from basic issues like schema drift or data type changes or bad reference data. So, things that machines and algorithms can catch, but manual reviews often miss. So, why this hurts? Forecasts are missed, marketing is spent in the wrong places, and compliance risk rises. So leaders see this as analysis paralysis because analysts spend a lot of time checking the numbers than using them. So a quick analogy is think of your pipeline, your data pipeline, as a river. It looks clear, but one small snag upstream, a new product code, a late batch, an extra delimiter in the data, that silently warps downstream metrics. So we call this the silent drift. And the static rules alone, the old QA era or the quality assurance era rules look for yesterday's patterns. They often don't catch new subtle shifts. So the real fallout is a dashboard shows, say, a fake 12% revenue drop, and there's a whole lot of panic. A war room spins up, budgets are frozen. Then someone finds a small misconfigured filter in the dashboard. So it's basically a time sink. Benchmarks show analytics teams spend almost 30 to 70% of their capacity on triaging and reconciling the data instead of value added work. So teams can automate this whole end-to-end validation, reconciliation, anomaly detection. They see big payoffs, 400% IRR, with finance teams averaging around 297% in the first year alone. So the bottom line is this: every day without proactive detection costs money. So we'll explain why legacy monitoring can't keep up. So traditional data quality feels like a factory check. So you test once, you say passed, and then you ship. So that worked when the change was slow, but it fails with today's fast changes, the schema on read analytics that we have now. So hard-coded rules age fast as the business logic and the sources change. Teams rarely update these rules until something goes wrong. So also another blind spot is the business intelligence layer. So most tools, data quality tools, stop at the data warehouse. The last mile, if you will, of the business intelligence layer, where there are calculated fields, filters, user groups, groupings, often isn't monitored, even though it drives the numbers the leaders see. Any kind of manual work like hand checks or SQL differences can't keep up with the thousands of tables and the hourly refreshes. As someone said, manual validation is insufficiently reproducible and dangerously slow. So an always on safety net that catches both rule violations, which is the known issues, as well as new unseen anomalies is needed. So we borrow ideas from software observability and apply them across data ingestion, transformation, data storage, as well as the consumption in the dashboards. So we look for freshness, volume, meaning, any kind of schema and lineage, and we set simple rules, say nulls are under 1% of the data, and run alongside these unsupervised models that learn about seasonality of the data and flag outliers. So the flow is to people spend more time on the insight, not firefighting. And we see up to 99% increase in data accuracy, 50 to 70% faster fixes, 75% less manual effort in customers adopting these kind of data observability and test automation platforms. There's also less time when you're migrating across tools or from across environments, and there's a lower QA cost, and this results in more reliable dashboards. So let's take a brief look at Datagaps and where it plays. So as I said, many tools miss the business intelligence layer. So Datagaps validates and monitors data from start to finish across the pipelines, the warehouse, as well as the business intelligence. So we pull data from several on-premise and cloud tables, flat files, JSON, APIs, Tableau, Power BI, and land it into a staging area. Here we are able to profile the data, and we compute 20 to 25 different checks for nulls, distinct values, ranges, patterns, outliers, and we compare what we see today versus what we saw yesterday to spot any meaningful drift in the data. And teams can add low code or no code rules for all the dimensions of quality: completeness, validity, uniqueness, any kind of referential integrity. And power users can build on that low code, no code foundation and extend it with SQL or Scala or other tools. And we independently rerun key transformations. We compare the results, catch the mismatches before the production. And our data quality monitor tool scores the data on how it's doing against the existing rules, sends alerts, traces problems back to the source. And with our BI validator, we test the visuals, the queries, reconcile the key performance indicators, the filters, the calculations across development, QA, production, and tie the metrics back to the lineage, so which is nothing but data reconciliation. So we are built for modern delivery, and we have hooks into GitHub, Azure DevOps, and other CI/CD platforms. And of course, we are able to incorporate generative AI to draft the test cases, the data quality rules, as well as the mappings for ETL to speed this process along. So the bottom line is this: you need both strong ETL as well as BI testing to prevent the nulls, duplicates, and unbalanced calculations. And ongoing monitoring proves the data health and keeps everyday decisions trustworthy. So I know we have a variety of audience here in our webinar, and I've called out some of the capabilities that appeal to different types of audience. For example, use the rules engine to encode business checks once, the completeness, the consistency, the duplicates, and you have these standardized controls. We have, capabilities for data scientists as well as data quality analysts, use machine learning based anomaly detection that learns about the normal volumes of data, the formats, the seasonal trends, so that you get fewer false alerts, but you also get early warning on any kind of silent schema changes, and you get to focus on the issues that matter. So for CDOs and analytics managers, you can use scores and trend charts to track the health of the data over time and see which areas improve or decline. And so the bottom line is these capabilities move teams from reactive firefighting to more proactive, measurable data that they can trust at scale. And this is, again, previously we talked about data quality monitoring. Here we are talking about data observability. And again, a range of capabilities that appeal to different types of users, ranging from analytics managers to data scientists to data quality analysts, and it's as well as data architects and CDOs. So, for example, the data architects would be interested in the lineage of the data and how it ties with the data quality score. So any kind of anomaly is tied to the upstream lineage, and you are able to roll up the scores by the domain of the data and so on. So all this helps with the business overall impact. It helps prioritize the highest risk fixes that you need to do, and it strengthens the auditability. So together, these features form a safety net, and business gets reliable metrics. Engineering gets to triage any issues faster, and the leadership sees clear trend lines. So I talked about the role of generative AI and how we have incorporated that into our platform. I want to talk about 4 of these AI accelerators, if you will. The first is, we know that manually writing column and table descriptions is slow and boring. And when the teams try to do that, the documents get incomplete or out of date. So the data architects and the engineers spend hours on metadata. The data analysts struggle to find the data, as well as the governance teams risk missing some key details about the data. So automated description generation for tables and columns, it keeps the metadata complete. It keeps the descriptions current and consistent without any kind of manual efforts. So you are able to discover data faster, onboard the data. You have stronger data governance and auditability, and there's less manual work for the architects and the engineers. The second AI accelerator that we have is about building the data quality checks. By when doing it manually is time consuming, it's error prone and often very reactive. So the generative AI fix is to auto suggest the rules based on the table and column metadata. So you've already generated the descriptions. So you're going to use all that metadata. The system analyzes the schemas and proposes relevant checks without all that manual effort. So common validations like null checks, valid ranges, uniqueness, referential integrity between primary keys and foreign keys, and any kind of drift is recommended as the data quality rule. So this broadens your coverage. It's faster to set up, fewer human errors, and it moves teams to be more proactive. The third accelerator is about getting these near real-time anomaly alerts. So the common problems are that pipelines silently fail, tables don't refresh, the volume suddenly drops or spikes, and schemas change without notice. So data analysts start to lose trust in the data, the leaders get bad numbers, and the fixes take longer. So the AI-driven observability watches for what we call as the 5 pillars of data health: the freshness of the data, the volume of the data, the distribution of the data, the schema, the lineage, and we provide near real-time alerts when something deviates. So this shows where teams can act fast your team is first to know, there's faster detection and repair, and it restores the confidence in the analytics and the dashboards. And finally, we have where when there is data that is drifting, manually watching averages on the value distributions across hundreds of tables is not realistic. So, for example, a numeric columns average may jump outside the normal range. A category shows up in an odd proportion. A data set could suddenly drop from, say, 200 million rows to 5 million rows. Or a schema change or an unexpected value may slip past the basic checks. So basically, it's hard to do everything manually. So we have machine learning based profile validation, which learns the normal patterns from history, the ranges, the distributions, the frequency, and it flags statistically significant deviations in near real time. So it acts like a 24/7 watchdog so that analysts get trustworthy data. And this whole anomaly detection is context aware. So by using contextual metadata, such as the table's purpose, the cadence of updates, Datagaps separates meaningful anomalies from the expected variation. So you're able to catch subtle issues before they hit the reports. You're also able to reduce the noise while improving actual positive detection, and you're able to protect the analyst's trust. So now I'll hand it over to Subhanshu for a live demo of all these capabilities that I just spoke about.
No. Thanks a lot for that. Let me start sharing my screen. All right. So let's get right into it. There are a few set of test cases that we want to cover. Since we are covering a wide variety of test cases as well as a few industries, we'll be covering them at a higher level. If at any point you have questions and if you want to have a deeper dive, firstly, the QA panel is right there for you to help us with the corresponding questions. And if needed, you can always set up a proper connect to delve into the specific problem statement that your team deals with. In the next 15 minutes or so, what I want to cover is a wide array of validations that we apply under the terms of observability and quality. And of course, we want to discuss how AI comes into the picture, making sure that the numbers you see at your BI report match the numbers you see at your database level, and all these numbers match the expected business rule and continuum that you're expecting from your entire pipeline. So with that, let's jump right into the application itself. So welcome to Datagaps. One key aspect that you will see within our product that I'm going to start with is that we are completely agnostic in terms of the data sets and databases that we want to connect to. All the connectors that you see on your screen work in an agnostic manner. So for us, it does not really matter if the data quality framework is being applied to a CSV file, a Salesforce object, Snowflake table, Databricks table. It's all the same for us and for the end user as well. One key aspect here is all the examples that I'm going to showcase can work interchangeably for all of these sources. And if you don't find something specific to your projects, like a connector, like say a CRM tool that you might be working with, for those we have CData connectors, generic connections, and API connections. And so in this particular fashion, we can define our connection to any particular data set and a good chunk of BI tools that we see in the market. Once you've defined this corresponding set of use cases, let's discuss our primary goal for today, which is data quality. So when we discuss quality, we distinguish them into two trains of thought. The first one is black box testing, and again, as the name suggests, the other one is white box testing. Black box testing is where you define a bunch of rules that you want your data set to follow. These rule sets could be something as simple as a demographics rule set on making sure your values are not null. This could be making sure that a particular foreign key does not have orphan records. It could be making sure that a particular attribute, which could be a column, which could be a value between certain ranges, follows those expected ranges and a lot more. To enable this, the application provides a zero code, low code template, which can be highly customized. And I would like to stress on both of these pointers. Our end users in many cases are capable of creating their very own custom operators as well, because it's very easy within the product to do that. And what this enables us to do is that instead of working with a set list of operators, which are ubiquitous, you can create your industry specific and more often than not project specific operators, which can have compound rules of complexities. You can have rule sets which combine multiple complex statements. It could be if else conditions in there. And from the end user's perspective, it is still as simple as just selecting the type of operator and you're good to go. That's one of the key aspects. Complexity while making sure everything remains zero code and no code. When this corresponding system runs, and one key aspect here is that the actual execution of the application can happen on your infrastructure itself. So you get to decide where the processing takes place. Is it going to happen in a Spark-enabled Databricks cluster, a Kubernetes system, or maybe a Snowflake table database itself, maybe your Postgres or Oracle system? There's a ton of options that we provide the end user, all within your infrastructure, so as to ensure that compliance is not being broken. We do have a SaaS offering, but as you can imagine, with most of our clientele working with PHI data in one form or another, the preference is to have the application installed and deployed within the client's infrastructure itself. For more details on this, we can have a proper discussion around this, so feel free to reach out to us on that. So we have defined that the application has a very robust zero-code, low-code system to create rules that can handle a ton of complexity as well. So what happens when something actually does fail? Well, critically, there are two sets of things that work with it. Firstly, there's going to be a segregation of good and bad records that we work with. That is an output of our rule set itself. That's one thing that we're going to go through. And I can even showcase that with a quick example right here. The only caveat difference here between the two is that I'm running a bunch of them for my file systems and I'm running another set of them for my databases. Functionally, they're exactly the same. But critically, you will see that we have segregated the data into good and bad records. And this is to enable the user with their post-validation processes. Of course, your worries are not solved away just because you've found bad records. You now have to perhaps fix them. You might have to go ahead with only the good records. You might have to send out notifications. You might have to create tickets. All this and more can also be thoroughly automated within the application. Apart from the segregation of good and bad records into different data sets, we also provide a proper DQ score. Now, this DQ score is very helpful. Firstly, as it's calculated at an individual rule level itself. So if a rule is breaking quite often, you will see that the application is going to keep track of such rule failures, and you can even customize the rule to call out if something fails only catastrophically as opposed to failing on a daily basis. After all, you can work with dirty data as part of your usual process. But the best part about this is that we are going to aggregate this system all the way to a DQ score that you see on top right here. That's one of the key aspects. This data quality score dashboard, which can be customized a lot, I'm going to discuss that towards the tail end of the demo. You can actually understand what the overall health of your data is, and if required, you can jump in and see exactly where your problem statements lie. If there's a particular data model, if there's a particular layer that's failing, why exactly is that failing? And critically, when something has failed, how do you keep track of that failure? For example, this particular rule set has supposedly failed in the past, and you see there are records which are bad and records which are new, which are still breaking the rule set. So how do we deal with this? That is where one of our most powerful use cases of data quality issue tracking comes into play. This happens for a ton of other use cases as well, where the application has the capability of keeping track of bad records which have entered your system. Of course, we segregate them automatically, but more importantly, we also keep track of when these are being resolved. So as an end user, you don't have to create individual tickets for this. You can just understand from which particular point of view these particular records have been resolved. And of course, if you want to, you can ignore them as well so that the subsequent run, these are not caught once again. There's a lot of nuance here that I'm skipping over, but critically, it helps the end user keep track of all the bad records they're working with, be it in terms of the record failing a particular rule or a record failing a particular type of reconciliation check. So if that happens as well, the application understands if for certain transaction IDs there was a mismatch. If they have been resolved, we can capture those as well. And that is the first part of DQ systems. Now, there's one interesting caveat here, which is if I'm going to create my data quality rule sets, I would like that process to be automated. And there are multiple ways to achieve that. One way, of course, is to manually create these rule sets. And as you can imagine, since we've been in this application for the past 13 years, we have had a good amount of automation along these lines. And quite recently, we have added the generative AI system. It's as simple as providing it specific prompts if you want to. Say I'm working with completeness in this example, and just asking it, selecting the corresponding rule sets along which you would want to create this. For example, say on name, some customer IDs, a few set of columns, and just asking it to generate the rules as is. So this is generative AI, so I do have my fingers crossed with every live demo. But what it should provide are a good set of rule sets based on the corresponding prompt that I've given. There's a lot more to this, which I'll discuss now. But before that, let's discuss how this is applied across multiple systems. You're going to create these rule sets, and each of these rules can be imported and exported across systems and easily imported and exported across environments as well. Reusability is going to be a paramount system because from what we understand, most data projects are going to have about 80% of reusable system, which can be kind of deployed across multiple projects. And so we want to enable that. And any customization that you're doing that can also be handled, not just by our custom operators, as I've discussed earlier, but even by the other set of templates that you're working with. So in this particular fashion, we ensure that your data quality is living up to par. But going back to our AI system, there's one more caveat that we can do. And for that, I'm going to be introducing Mapping Manager. So what exactly is Mapping Manager? Well, Mapping Manager is a concept that we have introduced where you as end users can either connect the application directly to your STTM files, like the one you see on your screen right now, or to your governance tools like Unity Catalog, Collabra, and other systems. Critically, what we are looking for are the transformation logics and the overall understanding of what the particular column should be. This is a gold mine, and in data dictionaries also play a similar role, and you can upload them as well for this particular context. And what this does is twofold. Firstly, it's going to create reconciliation checks. We will discuss them shortly. And more importantly, it's going to create AI-generated rule sets for you based on the context that we have defined. Now, how this actually happens is what I have planned next, but the critical aspect is that using just STTM files, you can automate the creation of data quality rules as well as part of your system. Now let's take a step back and see how we actually approach this as an entire system. What exactly do we do? How exactly we generate these descriptions and other aspects? Well, the way we do that is firstly, the application has something called as data models, logical isolations of your tables, and you can directly import tables between them. It's as easy as dragging and dropping. And what we do in this particular system is firstly, we inherit some sample data. This is a step that has already been done, as you can see. And then I ask the application to generate descriptions. This step is going to help the application generate descriptions of not just specific tables, but also specific understandings of what each column is supposed to be. And the reason this is helpful for us is in subsequent steps, when I want to apply some query to this, when I ask the AI system to create a rule for me on this, it is aware of the exact context on what this is being based on. Not just that, we keep track of the overall relations between systems as well. So there's a ton of information that the data model has that the AI agent can also work with. And that's our key aspect on description generation relations. Now let's see them in action. Let's actually see this particular system work. For that, I'm going to quickly jump ship into a bit of reconciliation. Let me open up an example where we do that. So when we discuss reconciliation, and again, this is an important part of data quality, it implies making sure that the numbers between your reports or between your data sets match. This could be aggregates. This could be the raw data itself. It really depends on what you're going for. And in an end-to-end scenario, you might want to do all of them. So if I start with a simple example, we'll wait for this particular system to load. And if I start with a simple example, it could be something as simple as making sure a CSV is being loaded into a Snowflake table correctly. It could be as simple as that without any transformations involved. And the application is indeed going to call out the mismatches, the differences, and everything that you see within a particular system. Okay, what exactly is going wrong between my source and my target? That's going to be a critical aspect. And as you will see, it works identical for any particular combination of data sources and targets. And that's our first step. We can identify mismatches, we can identify missing records. And if I want to, the application can then use the Copilot assistant that I just discussed to combine these data sets as well. And that is critically what we are trying to look into. In this example, I'm trying to ensure that a corresponding staging table is being aggregated correctly into a MAR table. If I go into Lineage, this has a better explanation of what I'm trying to do. So let's open up our Lineage system. So our Lineage here should be very simple. So here, as you can see, the application understands how exactly columns are related to one another and which columns track their descent from other systems. If I look at a bit more complex systems here, let's go to a MAR table here. You see we can keep track of them across multiple systems as well as part of our applications, part and parcel. And this entire lineage is also created using the mapping document that I have suggested earlier. So there's a lot that we are kind of coming together in this particular system. But from an end user's perspective, going back to reconciliation, I've just provided this information to the application and it has generated the query for me. However, this is not the intended method. I'm just showing off the Copilot that it can do a lot of complex queries. If you're going to generate unit test cases, the recommended method, once again, falls back to the mapping manager. Because here, when we're going to generate these particular test cases, when we provide the information on what exactly we are expecting this particular transformation to be, in that case, the unit test cases are generated at an individual column level. This is really helpful because we want to make sure that these test cases are generated at an individual column level so that if there are filters and other specifications which are applicable to other columns but not these ones, we are segregating them. After all, one of the biggest culprits that we have found for end users or developers misconstruing requirements is the fact that certain requirements pertain to only specific columns and certain requirements don't. So the initial creation of unit test cases at a column level and then aggregation is the optimum way to make sure that you're achieving proper validation at a finite level and also make sure that the egress cost is overall less. So you're not individually calling a unit test case for each and every use case there. And that's one point on reconciliation. And when we kind of combine all of these use cases together, what we end up with is an end-to-end validation use case, where the application can keep track of the data or the metrics as it moves from one layer to another. And if something is going amiss, we can tell exactly where those problems lie. And this includes, of course, the BI layer as well. Now, the BI validator in its own right is its very own 45-minute, 50-minute demo in true essence. But what we wanted to illustrate with this quick showcase is that if you have any particular report, the application has the capabilities of getting into them and fetching the actual information that's created by the report after the application of filters and slicers. We have access to the underlying data model. And again, this rabbit hole is pretty deep once we get the concept of filters and slicers in the mix as well. So if you have any questions on that, feel free to book a free trial so that we can have a bit more discussion on this. But critically, we make sure that the numbers you see all the way down to the BI layer are being backed up and validated against the data model, against the golden layer, and all the subsequent layers below it. Thus making sure that any controls that you define, and again, that's another way to put this, either it's data or it's controls, these controls are being validated thoroughly, be it across any environment or any other system as well. So we've taken a tour of the most important aspects of our use case, reconciliation, and of course, the data quality aspect. But we should not forget profiling and observability. At least that's the nodes that we call them. These terms are pretty ubiquitous, and in different industries, these mean different things. So let me elaborate on what we mean by profiling and observability. Profiling for us is creation of the aggregations and creating a kind of a template of what the data set is supposed to look like. Say you get a data set at the behest of a new project, and you want to understand what this data set is. What are the nulls? What is the distribution? What are the date formats that I've seen? For that particular one-time use, profiling is amazing because it gives you exactly what you're asking for, a proper understanding of what the table of values are associated, what the distributions are, if you're working with extra values, if you're working with values you don't really need, and so on and so forth. But when you do this at an intermediate level, basically if you do it day in and day out, because your data is changing, the application can make sure that it compares these profiles against its previous metrics. So in this example, we see that the average of this particular quantity is dropping from, say, in this case, 40 to 20, And we see that this drop is rather sharp. And so we call it out as an anomaly. But that's not the end of it. The best use case that I want to showcase is applying this on your BI layer as well. So in this example, I have a Tableau report. This is the Tableau report for reference. And I want to make sure that the bar chart and line chart here go through the strands of observability and profiling. And that's exactly what we do. I plug the report in. The application, firstly, is telling me exactly where a particular average has maybe shot up, or the volume has shot down, or any other permutation or combination of what you can think of. And most importantly, it can be applied at complex use cases as well. So now let's take a look at observability and what exactly that means. So this is the chart that was used in the slide earlier as well. And what this represents is realistic data in multiple ways. Firstly, you have three distinct categories, and one of them is overbearing. So that's the main use case. If you just do an average here, red is obviously going to win against golden and blue. So again, we can't really go ahead with that. Also, it could be that the red category has a different seasonality. Maybe it is, if the usual example I go for is with flu shots. If you are in a pharmaceutical domain, flu shots are going to sell more during flu season. And you might be expecting that rise. And for other categories, you might not have that in other cases. And so you have seasonality that you want to take into account. You have categorical differences that you also want to take into account. And this data, as you can imagine in this example, is coming in from the BI layer. But in other examples, it's coming in from the datasets layer as well, right? So we have to understand what the differences between the two are. But for the application, it's very easy. And as you can see, low code, zero code. Just define what the categorizations are that you're working with. Then define the aggregations. The cadences and the where conditions are completely optional, of course. Choose the type of prediction method you would like to go with. In this example, you'll see we have seasonality in the mix. You can also define fixed deviations, delta deviations. There's a lot of nuance here. But critically, what the application does is that it's going to segregate your good and bad records, once again, into different categories. So here we see express error, which is relatively stable, as you can see, from, say, -100 to or 200. Here, 381 comes out as an easy anomaly. But if you look at a different category, this particular category has a lot more variations. And it has a rise and fall, as you can. If you look at clearly, especially near these particular points where I'm hovering my mouse, this particular systems, you'll see that there's a lot of rise and fall, and only the extremes are supposed to be caught. And the application has successfully caught that all the way on your BI layer itself. So this is what our crux of what I want to discuss here is. The fact is that the application can find out if these issues are being done at an individual ingestion level and as well as at the overall data level. And now what I want to discuss is where exactly we kind of come up with everything together. And that is our dashboard. So these dashboards are completely customizable. These are automatically generated by the application as well. So individual test cases are going to generate specific reports, but you as end users, you can come in and define your very own widgets as well. You can define if you're going to keep track of schema drift, if you're going to keep track of the overall systems, the reconciliation checks, and a lot more. All of this is part of the product inherently and completely customizable. The best part about this is that this is also optional. If you want to use your own reporting section, say you want to use Power BI to showcase the data quality dashboard, that's completely fine by us. In fact, we can promote that by providing you a data model where all the results and other aspects are kept as well. So you as end users still keep a tremendous amount of control over what you are showcasing, what you're creating, how you're using it, and of course, the results being sent out as well. So with that, we kind of summarize the overall use cases. The one final thing I'll quickly touch base on, given that schema drift is very popular these days, is the fact that the application has these capabilities inherently as part of the system. As you can see, we can keep track of any changes that you see within our application from one system to another. And that's one of the critical aspects here. So with that, I would like to take a pause here. Thank you for going through the demo. And I'll hand this back to Anand to continue with the rest of the deck. Thank you, folks.
Thank you, Subhanshu. Great demo. Let me just share my screen now.
Yeah.
Okay. Are you able to see my screen? Yeah. All right. So thank you for your attention as we showed the demo of our product. We went through couple of differentiating capabilities that our product offers, focused on the schema drift observability, or the overall data observability dashboard, where we are able to see the anomalies, as well as the AI powered report validation that we have natively in our platform. So do check us out. There's a book a free trial button that's on your screen. So if you want a demo of the product, Subhanshu can gladly do that for you. And so we have done this with a number of different customers. So I'm not going to go through all of them, but just to give you a real world sense, let me pull up like three examples. Are you able to see my screen moving?
Yes, it's visible.
Okay. Let me just make sure. Because I see the live demo slide. Pooja, are you able to see the success
Yes,
story?
it's a live demo slide. Yeah.
Oh, it's a live demo slide. Okay, maybe I have to share again. Let me just briefly do that. Not sure why it didn't show up. So let me.
Meanwhile, if you any of you would like to go through a free trial, you can book a session with a button on the bottom right corner. Yes.
Yeah. Thank you, Pooja. So these are three customers who have used our platform. One is an ad optimization and marketing analytics company. They were looking to ingest up to 50 terabytes of data from 10 different sources. They were doing this every day. And the goal was to speed the trust in data and dashboards. So they had centralized monitoring of this data with parameterized rules. So they are flexible based on the parameters. They had near real-time dashboards and alerts. And the result was that they had the quality at 99.9% of what was expected. There was faster issue resolution when any issues came up. It was like the resolution time was cut in half or more. And then the overall vendor onboarding was also cut in half. So the impact is you have faster, more confident marketing decisions. The second example is a global research firm. We can talk about it in more detail. They needed accuracy across their entire data surface. This included business rule checks, regression on over 1,000 tables, Power BI validation. So they automated the comparisons, they detected the duplicates, and they had daily regression runs. The result was 50% less manual validation, and you had end-to-end visibility from pipelines to dashboards. And the impact was that it was consistent, trustworthy insights. And lastly, talked about a health insurer. This is regarding the regulations, the APCD files that need to be submitted. So it's a high compliance risk situation with hundreds of checks for every file. They need to use the state-specific templates. So each US state has a different template. They needed automated tests. The thresholds were different, so based on the different states, and they had to integrate all the notifications as well as Jira. So there was a 60% faster deployment. There was 70% faster validations. The overall quality improved by 95%. And they have had over 8 years of reliable runs. So we've been a company that's been around a while, and this customer has been with us for 8 years. So the bottom line is these proof points show that observability delivers at scale. It's continuous, centralized, actionable insight that grows with the data volume, reduces the risk, and lets teams move faster. So I wanted to quickly give you an implementation checklist so that you can have the baseline data observability. So you pick some critical data elements tied to the key KPIs that you have. Choose one or two pipelines or tables. You assign owners. You set the service level agreement and document who escalates to whom. You connect the sources and targets. You take the baseline schema snapshot. You profile the tables for row counts, nulls, any distinct values based on today's date. You add some core rules, and many of them will be zero code. So you create the rules for completeness, validity, uniqueness, and other business constraints. You group these rules into reusable sets, and then you ensure that you are watching for schema drift. You create a critical list of tables and columns, and you create alerts for them to look out for schema drift. And then you reconcile everything based on different tiers so that you have a graduated set of checks. You add anomaly detection where you monitor the metrics using several statistics that we have, like standard deviation or interquartile range, and you tune the sensitivity to reduce any false positives. And then we have additional tests, but you can make you can publish this dashboard and the scorecards, and you can set the alert thresholds. So you start small, standardize the rules, watch for the drift, reconcile the layers, make results available so that any kind of issues are fixed fast. So I would like to end with why you should think about us as you're thinking about your data observability initiatives and data quality initiatives. So Datagaps brings detection, testing, business intelligence, monitoring all together. So teams don't have to juggle multiple tools. We combine the statistical thresholds with machine learning seasonality to cut the noise and surface any real issues. We are built into DataOps. So all the testing, the validation, the promotion across environments are integrated, reducing the handoff time and speeding the time to value. We are able to scale. We have a Spark-based engine that runs the compute validating billions of records without costly moves of the data. We cover analytics, not just the pipelines. So we are able to monitor data in Tableau or Power BI reports and flag the stale dashboards and the slow queries. We have low code for analysts, as well as any kind of guardrails for the engineers. We are able to be deployed on-prem or on the cloud. All the major cloud hyperscaler platforms, as well as Kubernetes or Databricks. We support all of these. And as Subhanshu showed and I talked about, we have these generative AI accelerators. We are able to draft the SQL, as well as we have one system where you can profile, test, and reconcile the data. So with that, we went through a lot. Please scan the QR code, or you can contact us by clicking on this button that we have. You can also reach us at contact@datagaps.com. We are excited to help you turn your data into reliable production grade data for better decisions. Now we'll open it up for questions.
Sure. Thanks, Anand. And thanks, Shubhanshu, for insightful session and bringing the concepts to life so vividly. Now we'll take it up the Q&As. So very first question is, how do we observe the BI layer?
Yeah, I can take that question, Pooja. As I said, one of the differentiators that we have is that we observe the BI layer as well. We check for data refresh times, the data sources, the filters, the calculated fields. We learn using machine learning what normal looks like for the data, and we look for any kind of spikes, any kind of stale data, broken calculations, failed refreshes, and any slow queries. So this catches issues where the decisions are made and points you to the exact set of data to fix in order to help you make the right decision.
Right. Thanks, Anand. Next is how do we cut down noisy alerts?
Yeah, that's definitely, with all this machine learning, there is a chance of getting these alerts, false positives, if you will. So we use machine learning that knows which are the weekdays, the holidays, the seasons. So it understands the business patterns, and it uses dynamic thresholds to set the baseline for the region or the segment. So we have both the rules, which are the known checks, as well as anomaly detection, which relies on these business patterns. And we are able to use Lineage to kind of duplicate, group any kind of duplicate alerts, so you're not inundated with all these alerts, and you have fewer false alarms, and therefore you can fix the right alerts.
Thanks, Anand. Next is like, will this run at the scale of billions of rows and in our stacks on AWS?
Yeah, absolutely. So I touched on this. It works on all the on-prem and major cloud providers: AWS, Azure, GCP, plus Kubernetes, EMR, Databricks, Snowflake. So if it can push the compute to Spark, so you can validate where your data lives. So if it's Databricks or Snowflake, it can use the Spark clusters there. You still get all the schema, the volume, the distribution checks, and it's seasonality aware, any kind of BI monitoring and lineage based impact analysis is done for you. So you can always start small and then grow to billions of rows that require the scalability of Spark, and you get all this into it in an end-to-end view.
Yeah, thanks, Anand. Since we are running out of time already, so there are three couple of more questions which we will answer on mail. Is it okay?
And
And
I think that's good.
Yeah, and I would like to thank all the attendees as well for keeping for staying with us for this whole time. If you have any queries, please contact us today, and you can click on the button, and you will be redirected to a page where you have to just fill a form. Thank you, everyone.